So the thought I wanted to start planting in your heads is, I'm a futurist at Intel, along with our next speaker, Brian David Johnson. And it is our job to be looking forward 10 or 20 years and really think about how does computing change the world that we live in? How does it change different industries? How does it change society? And as we look forward, what we see is that computing changes everything and everyone. It's going to change the way we live our lives. And it's already been happening. We know this. I mean, you're in this room because you participate in an industry. You know that it changes people's lives. So let's talk about what that might look like as we wind things forward 10 or 20 years. My assertion is that computing transforms objects, it transforms entire industries, and as a result of that, it transforms societies. An example of transformational objects is something that you heard Renee talk about in her keynote, and I know we've talked about it, some research at Intel days before now. When you add two pieces of an idea together, and this is where something new comes from, you're typically taking two things that you had before and combining them in a new and interesting way. When you do that, you're not just making 2 + 2 = 4. If you do it right, you're making 2 + 2 = 11. You're getting to somewhere that's even better than the two previous halves of the idea that you had. And if you do it really interestingly, then 2 + 2 = lemon or orange or something crazily new that you wouldn't have expected. Computing has that ability. Think about the plain old car headlamp. It's been the same for about 140 years. If you look at car headlamps, say, think about how much innovation there is in them. Yes, it's a light source still pointing forward. There's some different optics in there. It's gone to halogen, and in some cars, when you turn the steering wheel, the lights move. But that's really the extent of the innovation that we've seen. But what happens when you put a computer into a headlamp? What happens when computing becomes so low cost that you can afford to put computing into every headlamp? What would you do with that? It turns out in our research that if you do that and you put a little camera in there and you turn the headlamp from being a point source of light to a projector, you can start to use that camera to look out of the front of the car, spot raindrops or snowflakes falling, track them in real time as they fall, and when you're projecting an image out of the front, instead of projecting a white light image, you just put you put black spots in there for where the raindrops are. You do that so that the light doesn't bounce back off the raindrops and glare the driver. It allows you to drive on a pretty much full beam all the time when you need to. You can do that with fairly moderate amounts of compute power, and successfully we're able to not hit the raindrops when we're driving with headlights now up to about 30 miles an hour. With more compute power, we'll get that speed up. It turns out it's a lot more difficult to do with snow, because raindrops tend to fall in a straight line. Snowflakes do this. So you have to have a bit more computer power to be able to handle that, and more complex algorithms. But we're getting there. We'll get to the ability to have a smart headlamp that can see through rain and snow. So sometimes you can take an object, and by adding computing to it, you can transform that object forever. You can do the same thing with plane wings. There's some research going on at Berkeley where they're adding computing into a plane wing. And by doing that, they think they're able to increase the lift by 100% in an aircraft because of the way they're using aerodynamics and looking at fluid dynamics of the air moving around the wing and controlling the wing surface in a different way. And they need compute power to do that, also floating point. So adding compute to objects changes them forever. And this gives you a view of what that looks like when you switch on this ability to see through rain. It makes a dramatic difference. Arthur C. Clarke, one of the visionaries of, I was going to say our time, but I guess it's former time, he said any sufficiently advanced technology is indistinguishable from magic. I think of computing, I think of the bow wave of computing that we get from Moore's law as being magical. Computing has become a magical force in our lives. For most people, now the exception is people like you in this room, we understand computing a little more than most. But for most people in the street, computing is this magical thing. They don't know how it works, they don't want to know how it works. It just magically transforms their lives. An example of how computing has changed an industry is if you look at the media and publishing industry. 30 years ago, computing started to make that transformation, this magical wave slowly moving over time and changing every aspect of the media and publishing industry. Think about media and publishing 30 years ago and how it is today. During that time, you've seen this magical wave sweep across. In the 80s, desktop publishing, multimedia capabilities in the 90s, video editing, all of the special effects and amazing computer graphics that are possible now, distribution over the internet, and now consumption on a myriad of digital devices. Any people in that industry that didn't comprehend that and embrace that change will run over, because it was completely disrupted and transformed forever by computing. And the next piece of this, we think, is this idea of digital storytelling. Creating rich digital environments, rich digital sets that allow people to very quickly improve the speed of production, reduce the cost of production, and then enable consumers to interact in a world. So if you're watching a TV show, then go and play in that world afterwards. Think about it like the merging of video games and TV production technology. But if you look at media and publishing as one example of how an industry has been completely flipped by technology, you can think about other industries and think, well, how is this magical wave going to sweep across them? Because there are some industries that really haven't been touched by it very much yet at all. Healthcare, in drug research, the number one tool that a drug research uses is a big fat computer, full of Intel processors, right? And when you go into the doctor's office, there probably is a computer in the back there somewhere. So your doctor, she might type a few notes on it. But really, healthcare hasn't been changed very much by computing, not like it has in media and publishing. We expect that is going to transform in the next 20 years, and there's a lot of effort to try and bring that in 10 years. And you heard a lot about that from Genevieve and from Eric Dishman on Tuesday. This idea of really using massive amounts of compute power to make medication, delivery of medicine much more personal. I'm doing a lot of work with my colleague Brian David Johnson on the future of retail. What will shopping look like 20 years from now? Manufacturing is likely to change radically. The ability to computer control things, to be able to scan objects, to be able to print 3D objects. It delivers the ability to potentially collapse the supply chain. So that instead of having a manufacturer, a supply chain, and retailers, maybe now you can go into the retailer and there's manufacturing in the back. Because consumers are very interested in customization. To be able to go into a store and say, I want that shirt, but I want it in that fabric, and I want it in this size, and I want it in 10 minutes. Okay, we can do that. This is the kind of thing that computing technology, advanced robotics, and a desire from consumers for customization might bring. And finally, you're going to hear a bit about transportation from Jen, that you're going to see radical transformation in transportation. That's hard to say. Transformation in transportation, because the big cities that we'll be living in, there's no way we can scale the transportation infrastructures that we have today. We have to increase utilization of those infrastructures and make moving people around much more efficient. Technology is going to have to help us do that, and compute will help us do that. So what are the three major constituents I see in this big wave? First is computing is going down towards zero size, zero cost, zero power consumption. It's not going to get to zero, but it's going to asymptotically approach that. What that means is computing can go everywhere. Computing is getting intensely small. On the other end of things, you're seeing these huge services, this infrastructure that allows you to get on-demand huge amounts of computing at any time. So computing at the same time it's getting incredibly small, it's getting incredibly big. Taking advantage of these two massive trends is going to be where future innovation happens. And the final thing is we're entering the Cambrian era of computing, where computers are starting to evolve the ability to see and hear the world around them, not to have a video feed come in, but to be able to visually understand what is happening. You saw some of that in the perceptual computing demos you've had. That's the beginnings of that. Over the next 10 years, you're going to see computers that can understand a scene, understand the relationship between objects, understand an object when it's held in a variety of different angles. The ability for computing to have eyes and ears. You combine all this together. My final thought for you. The intersection of opportunity is when you look at one of these three megatrends and you look at the intersection with one of these major industries. For example, in healthcare, that big healthcare opportunity, That is this genomics thing where you use huge amounts of compute power to personalize computing. The small in healthcare is wearables, ingestibles. So you can look at all these intersections. If you think about it this way, I think at every intersection you find an opportunity for innovation, development, and for changing the world. So with that, he's here, Fu, the other bald futurist at Intel. Please join me and welcome to the stage, Mr. Brian David Johnson.
Sorry I was late, and you will tell that it's been a very good IVF because I'm losing my voice. That's how you can tell that it's going quite well. What I want to talk about today is something I've never talked about before publicly. It's also something that we are publicly announcing next week. So don't tell anybody, right? So we're in this. I can see you all, by the way. I can see you. Somebody's tweeting. Ooh, let's close this out. I'm sure that's just for yourself. He's recording. It's just for you. I want to talk to you about this project that we have called 21st Century Robot, and tell you a little bit of the story, and then I'm going to introduce you to somebody today. And it's somebody by the name of Jimmy. But I want to tell you a little bit about how we got there, how we got to Jimmy. As you saw, Steve was talking about this notion of compute moving to zero. And this is something that's been driving our work. I mean, you saw that we announced 14 nanometers, you saw the Quark platform, and really amazing stuff. The size of computation getting so small that we can actually turn anything into a computer. And if you can turn anything into a computer, how do we design for that future? How do we design for a future when we could turn my shoe or my shirt or my body into a computer? How do we imagine these possible futures? And that's really what we do inside of Intel Labs. Well, one thing that we've been using, and I know some of you have heard me speak about this before in the past, is we've been using science fiction. We are truly living in a science fiction world. So what if we started writing science fiction based on science fact as a way to prototype out and think about these new futures? And we found it to be a very effective tool because really good storytelling is about people. And science fiction based on science fact allows you to prototype the future and understand the impact of that technology on people, on culture, on ethics, on any myriad of different ideas. So we've been doing this thing called science fiction prototype, and the public side of that is the Tomorrow Project, and I've come many, many years to IDF and talked about the Tomorrow Project, and we're going to be releasing a new Tomorrow Project anthology in just a couple of weeks, so stay tuned on that. But there's another side that you haven't really known about, and this is the work that we do inside, is using science fiction inside of Intel to begin to prototype out and think about these. These actually become a part of our specs. They become a part of the requirements documents that we use to build these platforms. One of the things that we started thinking about was, if we can turn anything into a computer, what if we could come up with a brand new robot? And that's what I started doing, and it was about 10 years ago. I started thinking about what would be the equivalent of a very, very small, low compute, a robot that we could all have. What would that robot look like? And I started collaborating with different researchers all over the world, in Kuala Lumpur, Malaysia, in the UK, in the US, and we started thinking about what would it be like to act and interact with these robots. And so we started coming up with this notion of what would a 21st century robot really be like. And this is Jimmy. Jimmy was our first example. Jimmy is a real robot, he has real artificial intelligence, and we were prototyping him actually in the science fiction. To say, if you had these robots, what would they be like if they were completely open source, if they were iterative, if they were completely social? Think about them kind of as the smartphone equivalent of a robot. It's there to act and interact with you. So we started over the years kind of prototyping this in science fiction and then also coming back and doing research. And we started getting to know Jimmy, the front of Jimmy, the back of Jimmy. What would he be like? What would that look like? And then we started thinking, well, okay, so what are some more robots that we could create? And so then we came up with Paul. So Paul's a very different type of robot, has a very different background. And then we said, well, probably Paul and Jimmy would probably be friends. And they would talk to each other. And what would that be like to have robots talking to each other? And then we started coming up with even more. So what would these other robots look like? And then, ultimately, we had this whole new set of different robots. And we felt that we were ready, and we wanted to roll it out. So we've come up with this idea of a 21st century robot. It allows us to look at other people's robots and go, oh, see that robot? That robot's so 20th century. We don't care about that robot. We care about the 21st century robots. And this is an example of our manifesto. That a 21st century robot is imagined first. We now have the ability to turn anything into a computer, so all of the development that we do, we have to imagine it first. Well, who do you want your robot to be? And how would you interact with that robot? The second is that it's easy to build. Using 3D printing, using open source hardware or open source software, having the ability that anybody could build a robot. Anybody who can imagine a robot could actually build a robot. That it's completely open source. That the design files are open. That the AI is open. And anybody can write an app. That you can start writing apps for your little robot. And also that it's intentionally iterative. And I think this is something that's important, is that it's one of the things that I wrote in a book that's going to be coming out about this is, why would you just make one robot when you can make lots of robots? And that's this idea, is that we're going to continue to make these robots and think about them and change them and then share them. And this is one of the things I think is incredibly important, that we can begin to develop these, share them in an online community, and then you can take my robot, I can take your robot, and we can 3D print them in different ways and create new types of robots, new ways of interacting with these robots. And the two final ones, I think, are really interesting. The idea that there is no line between technology and humanity. We imbue our technology with our humanity, with our sense of culture, with our morals, with even our dreams for the future. And everything we make has a little bit of us in it. So as we begin to make these robots and design them and build them, we can begin to see these robots as extensions of ourselves and allow them to go off and interact with other people, interact with other robots, and really kind of open up a really, really interesting platform for people to create as many robots as possible and very specific. And the fact that they have real AI, that they are thinking for themselves, they can go out and do things for us. And so, what I'd like to do is introduce you to this project, 21st Century Robot. We are announcing it next week at Maker Faire in New York City. And our motto for 21st Century Robot is every robot has a name. Every robot is an individual. You've imagined it, you've made it. Every robot is an individual. And so this project we're going to announce it next week. You will be able to go online and download the book that we've written about this book, 21st Century Robot. It has science fiction stories that describe Jimmy and all the other robots. And then it has these placeholder sections because it's a work in progress. You're literally kind of getting the open source code of this book. I'm still writing it. It gives you the steps to actually go and be able to build Jimmy. That you can actually go online and download the files and design your own Jimmy. That will have the specs online so that you can do it even in ways of being able to 3D print it. But we're not only open sourcing all of that, we're also being open about the development process. That we're going to go out and we're going to have a series of robot maker fairs all over the United States. We're doing one in Boston in November. I will know the date next week. Where we're going to bring people together and give them these kits so that they can begin to build these robots. And the only thing that we will ask them is that if you do something amazing, if you come up with something really awesome, share it with other people. So that we can create this community of people building 21st century robots. Now, in my whole talk, the reason why I wanted to have introduce you to Jimmy, because for me, it's this incredible moment in sort of research, we do research in the labs, and as all of my colleagues will tell you, you begin to think about these things and they live in your imagination. You live with them for a very long time. We've been working on these for about 10 years. And just this week, Jimmy started to be born. As we start to get ready, we're starting to print his exoskeleton so that we can take him to New York and introduce him to the world, and then we can start sharing. And in preparation for that, we've been sharing it all over the world. So I've been getting pictures all over the world that look like this. That's Jimmy. From science fiction now to reality. Jimmy is being printed as we speak all over the world. He's being printed in Malaysia, he's being printed in Finland, he's being printed in the UK, he's being printed all over. And that's the idea of the 21st century robot, is to enable as many people to imagine a future with robots and then be able to design them, program them, build them, and share them. And so if you're very interested in this, please, I encourage you to become a part of the community of building these 21st century robots. And as I said, this is a complete secret. No one's allowed to share any of this. It comes out next week. Shh, I trust you all. So I would like to bring up somebody which I'm a huge fan of, Dr. Jennifer Healy. She's been doing amazing work in transportation. So let's bring her up to the stage and please give her a big round of applause.
So I'm here to tell you that unfortunately car manufacturers have a huge problem these days. They make cars that are really, really good. Cars are amazing. Every time you go, you can turn the engine on and it just runs. They deliver speeds that are greatly in excess of anything you can do legally. And the handling, perfect, especially for the flat roads we usually travel on. These vehicles are exquisite. This is the Porsche Panamera Turbo. I love this car. And I had the great pleasure of passing this car on 101 in my 13-year-old Jetta because I know the ebb and flow of the traffic on my daily commute. That's local knowledge where I am an expert. I know exactly when to get in the left lane, exactly when to get in the right lane, and my underpowered vehicle was able to pass this exquisite masterpiece. And car manufacturers have exceeded all of our expectations in terms of what's required for our daily drive in this imagined world where we own the road and we can drive down a scenic mountain pass. And we really need that speed and that handling, but unfortunately, this is more like what is real. And we know that. And today's transportation challenges are really around this, traffic and, in the end, parking. They're about working cooperatively to share infrastructure in an intelligent way, in a way that can be managed intelligently by collecting the right data and sharing the right data between vehicles and infrastructure. Now, I'm part of Genevieve's team, and when we want to explore what's real, we go everywhere. And over the past 2 years, we've been going around the world to interview people about what are their local experiences of automobility. What is it like for them to use their cars on a daily basis? We went around the world. We did deep ethnographic interviews with people in their cars, in their homes. We unpacked their cars. We saw what people carried or didn't carry with them around the world, all the things that they needed for their transportation journey throughout their day. And then we augmented that with technology. We put sensors in their car. We put apps on their phone. We put a GPS in their car, and we let the technology embed itself in their lives for a month. And then we looked at the data, and then we went back and we had a second conversation with these people, showing them the reality of their drive and getting them to reflect on it with us so that we together could catalog where their pain points were, what they loved about their daily journeys, and where the real issues were in transportation for them. And here are some of the things we found. Local knowledge of traffic, up-to-the-minute local knowledge of traffic is important for routing. We looked at this and we're like, what is this? Why is this person just making, what is this strange U-turn? We saw this ubiquitously throughout Wuhan, China. It turns out it's just impossible to make a right-hand turn. And that the right route is to go forward, make a U-turn, and then make a left. No, how would you know this? This is local knowledge. What we need is that local data. How do you get people where they need to go faster? Potentially by logging GPS routes and sharing data that is context dependent, potentially in 5-minute increments. What's parking really like? I mean, people say parking's a problem, but when you see a trace like this from Munich, Germany, about a man who had to spend 1 hour finding parking. His friends, he dropped them off at this club, and they actually had to come out and bring him a Coke because it was taking him that long to find parking. This is a real problem. I don't care how fast his BMW could possibly go. He couldn't park it. And he was not having a good experience that night. And he said if he had known, he would never have gone. As Genevieve mentioned in her keynote, people never text while driving, except if it's an emergency, like checking into Foursquare or checking, Google Plus, or checking into Foursquare. That's an emergency. And they do it at speeds. I mean, 70 kilometers per hour and higher is the green speed in these graphs. This is what people want to do while they're on the road. Even if they're not in traffic, they want to connect beyond the vehicle, to let people know where they are, what they're experiencing. Another interesting thing we found when we put an app on people's phones to try to look at what they wanted to do while they were driving is that somehow they seem to be playing a lot of video games while they were driving. And this is very concerning. Why are you playing fishing games and Talking Tina and Fruit Ninja really while driving? Okay, guess what? We found this out when we returned with the data to the people. They had actually given the phone to their child while driving. Thank you. That's much better, but even when they're not supposed to, even when it's their company phone, because having your child entertained in the back seat is very important to your experience as a driver, because it's not like mommy, 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 mommy every 5 seconds. So this is the real experience of transportation. These are the things that people are really trying to do in their car. And I believe these interviews have outlined a design space where we can start thinking about innovations that are truly going to improve the transportation experience beyond creating faster engines or better handling. And as you know, our group is interdisciplinary, and we took these ethnographic findings. We sat down with designers and technologists across the labs, and we tried to bring these findings together and create a vision of where we believe the true opportunities for development are in the transportation future that is driven by data. And we put it together in a lovely vision video. I don't know how high the cheekbones are of the people in the video, but hopefully you'll find our data at least to be very beautiful.
Over the last 100 years, the automobile has transformed our world. Cars have freed us, but they've also led to challenges in safety, congestion, pollution, and isolation. We have the opportunity to change our future. Through advanced sensing, interconnected data, and intelligence embedded in our cars and the environment, we can create a transportation system that knows who we are and where we need to go. One that's connected and cooperative, easing the burden of driving and making transportation safer and more efficient. Age 15, Tuesday morning. A parent, his child, and a classmate leave the house on their normal drive to school. They each have a unique data profile of their travel preferences, routine destinations, and upcoming trips. As they approach, the car securely links to this data. Inside, the car recognizes its occupants and the trip they're taking. Utilizing their data profiles, the car dynamically adapts to them, changing in-cabin settings, music and media, fuel efficiency, and driving performance. Anticipating their destination, school by 8:30, the car displays the different routes they normally take. It accesses real-time information about delays and helps them choose the safest and most efficient path. In the back seat, the children start a game. This game allows interaction with the outside environment as they pass by. mother checks her phone. Traffic is heavy on her normal commute to work, so the transportation system offers her an incentive if she takes a different route and leaves a few minutes later. When she enters her car, her mobile device seamlessly and securely connects with her vehicle, displaying her chosen route and relevant trip details. As she drives, her car senses and communicates with the environment around her. Connecting with an upcoming traffic signal, her car tells her that the light will shortly change to green, as no other vehicles are detected at the intersection. To enhance her driving, she's given an augmented view of the world around her. Dynamic driving zones, in this case a virtual bike lane and a school bus zone, make obstacles normally obscured suddenly visible, helping ease the flow of traffic. Knowledge of road conditions is shared in real time between vehicles, allowing drivers to avoid obstacles and hazards before they're encountered. In this case, an approaching car is alerted to the delay and an alternate route is suggested. This car merges onto the freeway, linking to the vehicles around it. They share their general destination and where they're exiting, forming an impromptu group that begins to drive together autonomously. As the car nears the driver's destination, it connects with local infrastructure to find available parking. Accessing data collected from sensors and other cars, a location is negotiated and reserved, taking into account cost, safety, and driver preferences. Over time, increased intelligence, sensing, and connectivity in our cars and the infrastructure around us will change our experience of travel. We'll work together, individuals, groups, cities, and governments, to travel more safely and efficiently. And our very idea of transportation will shift to one that is more sustainable, cooperative, and ultimately freeing.
That's our vision for the future, and one thing I'd like to point out to you, where I see the car as just another mobile device in an ecosystem of mobile devices that will help us manage our data and manage our lives more efficiently. We're working hard to make this a reality. I hope you had a chance to visit the Tizen IBI booth. It's an OS that's particularly designed for transparency and speed in the vehicle and connectivity to the external world. And I think there are so many opportunities in the transportation space that will help us make our lives better and improve our cities with better efficiency and better use of all of our resources so that we can all get where we're going the fastest and most efficiently and most enjoyably possible. And with that, it's my great pleasure to introduce Dr. Tony Salvador, a man I admire greatly and a man whose championship belt buckle I admire greatly.
Thank you, Jen. So I'm one of the social scientists that works in Genevieve's group. And today what I want to talk about is a little provocation, just something for your consideration. And it's an area where we're moving forward, and it's based on the work we've been doing related to data that we talked about on day 0 and that you can see on the web. And I want to start with a little story. About a dozen years ago, my wife was running the Portland Marathon, and my cousin from Italy, I have cousins in northern Italy, and he was visiting in Oregon at the time, and we went down to cheer my wife on while she was running. And we got to a coffee kiosk, and it was early, he was jet lagged, I wanted coffee, I live in Oregon, and we said, hey, Fabio, do you want, and his name is actually Fabio. So, Fabio, would you like a coffee? Yeah, that'd be great. And so I went to get him a coffee, and I realized I didn't know what he wanted, so I turned around, hey, what kind of coffee do you want? What? What kind of coffee do you want? Mocha, latte, cappuccino? Oh, cappuccino. Okay. Oh. What size do you want? A small, medium, large? Oh, medium. Right, okay, medium. And said, what kind of milk? Because she keeps asking me, the barista, what kind of milk do you want? Non-fat, 2%, what? I said, just milk, just get me a coffee. Right? And so I got him a cappuccino, and I gave it to him, and he tastes it, and he says, this isn't a cappuccino. Right? And the thing is that he wasn't kidding. He was serious. It wasn't a cappuccino. It wasn't his expectation of a cappuccino. It was a customized coffee, but it wasn't a cappuccino. He knows what a cappuccino is because he's from Italy. He's from where they invented the cappuccinos, up in that northern region there. He knows what a cappuccino is. And if you know anything about Italy, you don't customize your food. Food in Italy is designed exactly as it needs to be. Now, there's a little bit of variation. I mean, a bolognese sauce can be good or better, right? But it can't be bad, and you don't modify it. You don't tell the chef what you want to do. Well, the same thing with a cappuccino. There's better ones and, better ones, but there isn't any way to modify one and customize it. And so the issue that we start to think about is customization and expectation. And we customize everything. So when we customize, we create a sense of expectation for ourselves. We customize t-shirts, we customize our cell phones, we customize our coffees, right? We customize our laptops. There are executives that we know that get, new laptops every week, right? All customized for them so they can test them all out. They don't do any of the work to actually customize it, but they actually get it done, right? If you're rich, you can get, a personal architect. You can have personal shoppers. They can go out and find clothes for you. You can have a personal designer to design the house that your personal architect actually built for you. You can have a personal assistant that is your personal representative to the personal architect and designer. You can have all of these personal things. If you're really rich, you can get your own personal genome, right, which you already have, but it can become revealed to you. And then that genome can be defined into all of the different genes, and that's what we're working towards. We're moving in that direction. And then if you're really good, right, we can start customizing those genes. Sometimes you call that healthcare, right? But sometimes you might call it just hair color, right? And then we can start imagining customizing those genes at different times in our lives. And clearly that's science fiction. But we can build on that a little bit, and we can suggest that, well, what about in the virtual world? If we have access to all of our data, and if more and more of what we do is becoming digital, and so everything is digitized and everything is data, we can imagine a personal, virtual, digital genome that is ours. And people have talked about this. And we're starting to work on what that actually means relative to customization and expectation. If we can imagine a personal, virtual, digital genome, PVDG, right, how are we going to actually express the genes that are defined in that genome? Is another question that we would ask. And then we start to think about, we need algorithms, and we need to write algorithms to actually, meet our expectations and take care of our data and do things that are really important for us. And then what we need are people to write those algorithms, and we need them to write them for us. And now we have Genevieve's 7 billion human problem, right? Because when we have 7 billion people that want customized algorithms for all of their data, we don't have 7 billion developers, right, yet. But we don't have 7 billion developers. We have a lot of you, we have a lot of other people, and what I'd like to suggest is that we can catalyze a personal algorithm developer network. And I think we can do it. And I think we can do it because there's enough variation in what people have in their data, but also enough commonality. And there are enough developers and enough people writing algorithms that we can start to match algorithm writing to expectation requirements or expectation needs given data sets. And and there's a couple of things about that. If we have a personal algorithm developer network, then it's kind of a massively open, kind of a Wikipedia of algorithms, people contributing all these different algorithms to what people need to meet their data requirements, their data expectations, their customization expectations. And we need people to pay for it. Right? I think that we need people to pay for it, and I think people will pay for it because people have paid for customization, like all those examples I used, like my belt buckle, which I customized with a man with a laser thing to make belt buckles. You can all stop looking at my belt buckle now. And so people will pay for customization if it delivers on expectations and delivers value. And I think that you can't have it as a person, one individual, one personal developer, one personal company. It needs to be a network because there's too much personalization. There's an enormous amount of data out on the internet, as everybody talks about, and the idea is to filter that down and bring it down to where it meets individual expectations on a regular basis. And so I want to end with 3 little examples about why I think this is a hard problem and why I think this is a human problem, because it can't be automated away. The first is TV. We know from a lot of the research that we've done that TV is essentially a push medium. People who watch TV want to watch TV. They don't want to manage their TV. And we know this. It's been resistant to all of the different ways of actually managing TV. But people also want to find new things on TV. and we know that. So thinking about how to customize the new that is relevant to a particular individual on a going forward basis will require judgment from people who understand what the individuals that maybe look like me are like. So that's the first one. The second one is a hotel for vacation. And you think it's all easy. And some people make it easy. They just pick a particular resort and they say, I'm going to that one every time I go. But other people want something a little different. And the thing about going on vacation to a new place, I don't know, pick Florida, Key Largo or something like that. The thing about going to Key Largo is that after you go there the first time, you know where you want to stay the second time. Because you've been there, you've looked around, you've seen it. How do you replicate that in some way that matches your own personal proclivities, your own expectations, given the things that are of interest to you? I think that's a human judgment matter. There's lots of automation that can help, and there's lots of neural network kind of technology that we can build on, but then in every case, there's going to be something new that gets added, and that requires human judgment. I think there's a personal developer in that future. And then the last one is one of my list of deceptively hard problems, which is personalizing the news. A lot of people would like to personalize news. We have lots of examples in their own research that we do of people saying, I really wish I could personalize the news. We had one guy that was in one group once we were working with, and we had shown them a skit and people on stage pretending that they were doing things, personalizing the news, and this guy kind of raises his hand and is like, I would love to be able to eliminate sports. I don't like sports. I never watch sports. I don't want to have any sports in this stuff, right? And I was like, all right, no sports. And then there was another woman in the group and said, I don't like any sports either, but I really like the Olympics. I kind of want to watch the Olympics, and I like the Olympics because I like gymnastics. I kind of want to watch those. And then the first guy said, I do kind of like the Olympics. Right? So I don't know what to do about that. And the thing about news is that news isn't just about you. News is about us. Right? So in one case, I want to watch the news, I want to see the news, I want to read news, but it's not just about what I want, it's also about what I need to know because I'm a part of us, a part of society. And I know that, and we're aware of that, and everybody who watches the news is kind of aware of that, actually, whether you think you are or not, you are. Right? So we're sort of collectively paying attention to the news. And it's also new, right? I don't know if news comes from news, but it is new, right? And so it's really hard to automate away, because something that would fit into certain categories clearly doesn't fit into the next category the day after. And how do you know when something is relevant to you? I think there's human judgment there. So personalizing the news, it turns out, is very difficult and requires constant tuning as you go forward. So I'm suggesting that there needs to be something called a personal digital genome or a personal virtual digital genome that's built on your data. I'm suggesting that there needs to be a network of algorithm developers on a going forward basis. And I'm suggesting it because I think that figuring out personalization and figuring out what customization means to meet expectations, and we all have them, and we're going to continue to have them, and they're going to get increasingly strenuous on the developers, is a human judgment issue. And that's what I have to say today. Thank you. I am going to introduce Mike. Some of you may know Magic Mike from the movies. This is Music Mike, and don't look at his belt buckle.
I'm no dancing today. I want to talk a little bit about music to start. And this is my daughter, Abby. She's working on 11 now. She was about 3 at the time. Music is a pretty important part of our house. It's a big part of my life. I write music, I create, I record with many different people in many different ways, in many different locations. That's a big part of my house. Music is always on. There's a quote from a friend of the family that I think sums it up well: life would die without music. If you walk into my house, music is playing. I'm expected to curate. If you walk into my home, people expect that music is going to be curated for them, and they're going to discover something new on that day. And it's a big part of my life in all ways. Technology has really broadened my experience with music. This is the backpack here is my mobile pleasure station. This is me on the beach with a wireless jam box in my backpack. It's raining, so I had to protect the wireless music system in my backpack. I'm using my phone at the time, where I have access to Rhapsody, Pandora, my personal music library. And we're on the beach, jamming out, having some fun. There's more to the mobile pleasure station than just music, but that's all I'm talking about today. And yet I'm pretty narrowly understood. With everything that music affords me, the access that I have to all different types of music at any point in time, I'm really not understood. nobody's really paying attention to what's happening in the car when I'm driving. Nobody's learning about what my daughters are listening to in the back seat, what my wife and I have on in the front seat, what we collectively enjoy listening to together. Nobody's paying attention to the concerts we go to and the music that we enjoy at those concerts and tying that back to the musical experience I have. Each of the music services that I participate in, they start to understand me pretty well these days. It's come a long way. They're learning about me, they're understanding me. They're not talking to each other. The things I do on one service aren't understood on the other services. There's nobody blending and helping to curate for me. I'm still responsible to do a lot of that for myself. There's nobody who's paying attention to when I'm performing versus when I'm recording and helping me to find new types of sounds and voices to introduce into the music that I create. And there's a lot of room for innovation. And the reason that I tell you this story, one, is to just introduce you to me a little bit. And two, what we're trying to do at Intel, and the reason that I wanted to talk a little bit about this today, is when you think about design at Intel, it's a different beast. We're not, for the most part, designing consumer products that are going to be in your hands or applications that you're going to use in most cases. We need to understand the broader systems that are in play. And to do that, we're trying to understand life. You know, it's not just about moments. We're not trying to design just features and just moments. We're trying to understand the breadth of life and what happens in the context of that life throughout the day. And once we do that, we can create these systems that really maximize the potential for the experiences that we can have across our systems, across our services. And we're trying to feed that into what Intel builds. What are our opportunities from the silicon all the way up through the experiences that you heard Genevieve talk about today? And what are our opportunities with our partners and the developers that we work with to create these experiences? And how can we be a better us at Intel in creating systems that afford this? And so we're looking at these life systems. Transportation, as Jen talked about, is one of those systems. And part of what I love about the research Jen talked about is that it really highlights the best of what we do in the Interaction and Experience Research organization when we pair this research. We're never trying to look for one data point that tells us what to do. We're trying to blend a variety of data points and insights about what people are doing and how they're doing it that help us to understand where there's opportunity to deliver new value. And in Tony's organization, a big part of what they're trying to do is not only understand where there's new opportunity to deliver value to people, but where's there new opportunity to deliver value to the business? And how are the business systems changing? How are the ecosystems changing so that we know where those opportunities lie? And there's more to it than driving. This is a shot right out of the vision video that Jen showed you. And the reason that we do visioning is not because we imagine that the bright futures that we paint are necessarily the ones that are going to become a reality. They're bits and pieces, and the essence of those things that we show throughout those visioning pieces are the things that we think are at the crux of the matter. These are the inflection points that are going to make most sense as we move forward. And in driving, it's not just about that driver who's moving the car around. It's the passengers. It's the social relationships in the car. It's the people coming and going. There's a trip on the previous slide. I think it was the trip in Beijing, China, where there's a man who's responsible every weekend to drive around his wife's family members to their various commitments. He spends about 3 hours in the car doing this. People are coming and going in and out of the car. He's rarely stopping for more than 5 minutes at a time. And there's a lot happening in that car that's not just about him driving. And understanding that is critical to designing experiences that make sense, whether those are entertainment experiences, travel experiences, or whatnot. And the systems to be understood are extensive. We're trying to understand not just what's happening with the passengers, but what's happening with the ecosystem. The OEMs who are manufacturing the cars, the IVI systems that are going in aftermarket situations. How things are going to change when you have connected roadways and cities where governments and cities are playing a much more active role in what's happening in vehicles and the entire transportation system. That's all part of us trying to figure out how we can create better systems and platforms for developers to create these 7 billion futures that Genevieve speaks of. Learning and education is another example, and sort of I just want to go through a few examples to give you some, I guess, a range of examples of how we work in these spaces. Tony actually used to run design and research for the Intel education team and now we still continue to work very closely with them at Intel. But learning is a great example, because as we think about technology to introduce into the classroom, it's not just about what we can do to put books on tablets or PCs in the classroom, or just about getting fresh content and interactivity for a child with a screen. We don't want to put a barrier between children and their teachers and each other. We have to understand how classrooms are changing. The classroom environments are changing in very different ways in different countries, in different cities, and we're trying to understand that. And in many ways, classrooms are becoming more project-oriented, more collaborative, and designing technologies that afford that collaboration, bring teacher and student to student closer together, are important. It's important to understand that entire sort of classroom system and what's happening in order to bring technologies to bear on that situation that are helpful and better that experience. But there's also broader systems at play. There are governments who are making decisions about how education is going to change, where they're going to put their dollars to afford these technologies, and there are cost-value trade-offs, and there are a lot of things at play that have to be understood if we're going to design solutions that are meaningful and actually make their way into the market. And this is another great example of where the broader systems are a big piece of what we have to understand when we're trying to design future experiences at Intel. You saw on stage Matt Yordana, who's in the back of the room, I see him back there, talk about social broadcasting. And it's not always the case that we're living in big, wide spaces and just trying to understand those systems. As we understand those systems, we're working towards designing, prototyping, and instantiating solutions that we think make our way towards those futures. And we take steps and we put these out into the world and we test them and we trial them. This is the social broadcast or the personal billboard solution that Matt showed on stage. And this is a really interesting step towards something that we think is much bigger about how people transition through the day, the things that they do from the time they wake up to when they're in the workplace or outside of the workplace, but thinking about work, to when they're taking a moment to connect with a wife or a child throughout that day, and how they're transitioning and moving and collaborating and sharing. And this is one example of how expressing oneself and getting connected locally with people we believe makes a lot of sense, and the initial research shows a lot of value here, but we're not done testing this idea, and this is only the beginning of many things that we're going to be doing that look at this bigger space around transitions throughout the day. And when we test these things, we test them in the context of life. We put these things out in the real world. We may start in a lab setting where we're working with people who may use these things and testing on certain things, but to really understand how these things blend into daily life, we actually have to put them in the context of daily life. And so IXR, or the Interaction Experience Research Organization, part of what's important to know is we're anthropologists, we're designers, we're human factors engineers, we're technology researchers, and we're software and hardware solutions developers. We try to bring all this together to create solutions and systems that make sense in the context of daily life. And when Genevieve talks about designing for the next 7 billion futures, we're trying to design for the fabric and the infrastructure and the systems that are going to afford those things. Whether we're talking about data structures that start to learn and understand you across devices, across services, whether we're talking about interacting with the environment that you're driving through in an automotive experience, whether we're talking about future wearable computing, these are things that to understand them is to understand them in the context of daily life and to understand how they all interact and fluidly and work together. And to do this, we're also trying to comprehend all the different developers that are going to be a part of building those 7 billion futures. And the picture in the upper right-hand corner here is at one of the Maker Fairs. We're an active part in that. Brian talked about how he's going to be at Maker Fair on the East Coast next week. We're also sponsoring and a big part of the Maker Fair on the West Coast in Portland this coming weekend. And there are all sorts of developers. The tools are being generated that allow people to build and create and generate computing experiences at all different levels. And we want to be a part of understanding the life systems that are going to afford new types of experiences and help developers of all sorts, from you here to the developers who are sitting at these tables who are in grade school, high school, and college, to build great experiences. And to do that, we have to fundamentally understand the systems at play during daily life. Thank you very much. This is my daughter with a Makey building her own guitar last year at the Maker Fair. Figured a fitting way to end. So thank you very much. With that said, I want to introduce one of the most entertaining men that I know, Peter Bell.
Okay, so the name of my talk is Code Talks and Bullshit Walks. You know, not just say bullshit on Intel slides. Making the future one commit at a time. There's a guy named Dave McClure. Does anybody know who Dave McClure is? VC? Right? Yeah, he's got a tremendous potty mouth. I aspire to be able to even approximate his level of potty mouth. He did a keynote, which was a riff on a Louis C.K. comedian's thing. His thing was the future's, what was it? Everything's great, why am I so unhappy, basically, why am I so miserable? And Dave's take on this was a sort of turning that on its ear, and that was, everything sucks and nobody cares. And the hook for that whole thing, right, which is kind of ironic for me coming on the stage, because it was sort of like doctor, drop out, is you don't actually have to be smarter than sort of everybody else. You don't actually even have to be as smart as everybody else. What you have to do is you have to do something, like one thing, 2% better. That's it, right? Everything else you can basically steal. Like all these fantastic ideas, right? Like you don't have to come up with a genius idea, which I'm just still making my brain explode, about using LCD projectors as headlamps. I mean, that's really freaking cool. But you don't actually have to come up with that idea. Now that you've heard that idea, what's the next thing you can do? How do you make that? How do you take something like that and make it 2% better? And that really was what Dave was talking about. And so my sort of closing talk here is to look at my notes. Is to talk about executing on great ideas and executing on changing the future, rather than to talk about the actual sort of notion of being really smart about stuff. Okay, so number one, shut up and commit. So there's an intentional pun here. Obviously, if you're a developer, you know that committing means you've committed your code. If you're continuously integrating, then you're doing that all the time. If you're sort of an old school developer, then you're doing it another way. When I was at a startup, which is right before I joined Intel, I had this awesome developer who, Polish guy, early 20s maybe, incredibly smart. And he would do like 28 check-ins a day. And it was the weirdest thing, like culturally for me, coming out of an operating system environment and building a product that takes, if you remember how long Vista took, you can remember how long it takes. And he was doing these check-ins all the time. And we had to come up with like a rule that you couldn't do check-ins after 2 o'clock in the morning, because who's going to do your buddy build and who's going to call you up on the phone. He really sort of made me start to think about this notion that it's really just shut up and commit. It's you've got code. Code is how you change the world. Shut up and commit. Just ship it, do it, get it done, get it out there, iterate, fix it, make it better. This notion of iteration is incredibly important, and I love the stuff we were talking about. Brian David Johnson. You noticed you have to have 3 names, so I have to be Peter Nicholas Pope, Brian David Johnson, Brown. Anyways. So shut up and commit. And another thing that was really a big lesson for me was our startup was doing social network analytics for enterprise. This was 5 years ago, which is a tragedy from my perspective, because if we were doing it now, it would be like so epically, incredibly amazing. But 5 years ago, it was a hell of a site. It was a real slog. And he told me, I'm leaving, I'm quitting tomorrow, right? And I'm going to this startup across the street, Last.fm. And I said, what are you going to do? And he told me the job. And I'm like, dude, that job sounds like it's going to suck. I mean, like we are arguing about PageRank versus K-nearest versus support vector machines and Bayesian and graph inversion, and you're going to go over there and basically do QA? Like, what are you thinking? And he said, 6 million users. I'm like, what? 6 million users. Like, I go there, when I do a commit, the next day, it's going to hit 6 million users. We don't got any users. So I'm leaving. And that was another big lesson for me. I was like, okay, this notion of changing the world, yeah, you can, if your code's not running and it's not doing anything and people aren't using it, then it doesn't really matter if you wrote it in the first place. So that was another big lesson that I learned from my young engineer, and that is that shut up and commit, and then shut up and commit into a system that's capable of actually making sure that your stuff gets used. End of life. Right now, if you've come at software sort of like I have. You tend to think it's like very cyclical. It's cycles, right? There's basically the brainstorming. Let's try a bunch of stuff, right? And then you've got the figure it out, get serious, right? And then you build it, and like there's you think of it as being like there's an end. And I am here to espouse the notion that you should never think of it as having an end. Like you're never done. Like whatever it is that you're doing, from an engineering and a development perspective, it's enormously scary on the one hand to think, it's never going to be done. On the other hand, it's incredibly liberating because it means that you don't have to have such high standards for yourself that you expect for it to be perfect. Right? If there's no end of life, if it's just all part of a continuous stream of awesome, or 2% not suck, right? If you're David Poor, then you don't have to think about it being perfect, and you can just shut up and commit, get it out there, and make it work. Another kind of, when I think about end of life, my father passed away about a year ago, and one of the results of that experience in my life is I am the proud owner of, I think it's like 278 axes. 278 axes. I mean, by the way, an axe head is heavy, right? So I have these burlap sacks and these axe heads, and I came up with all these genius ideas for what am I going to do with 300 antique axes. So I'm thinking about this notion of there being a continuum. I think there's both a development opportunity as well as something for all of us to think about, and that is technology basically creating an N+1 axe head problem, so that when we pass away, our siblings or children or the inheritors of our awesome are going to be stuck with the digital detritus of 75 years of accumulation without any management and anything, right? And I think about all the hard drives that I've got, that I've plugged into things and backed up and then forgotten about that are all over my house. And I'm like, God, do I want my kids to look inside those? I think there's actually a really interesting set of business opportunities there. But just taking that as an example, you can imagine, okay, so how do you want to be 2% better at helping people do that kind of stuff? Well, if you had a way to sort of centralize the notion of essentially, like a rights management system that said, okay, there's sort of a break glass in case of whatever, and you could auto-rank stuff as being things that you really want to make sure it gets destroyed infinitely, when you die, versus is recoverable, right? That entire space is actually quite interesting, and it's particularly interesting because I think that my generation is going to be, we're not digital natives. We're we're not natives. We're not boomer or that. We're Generation X, and we've got a lot of drugs, but other people money. But we are actually going to be the first generation to we in this room are going to be the first generation to die natively digitally, right? Which actually is a fascinating thing, because what it means is, and this is part of there's no end of life, right? Like our Facebook pages are going to live on, right? Facebook is coping not very well right now because it's a really weird issue to do social media around people passing away. That entire space, actually, you could probably say you're going to be 2% better at helping people deal with aging relatives, and you would have a kick-ass startup. Who needs Will McAvoy? It's not enough to just be a great coder. You also need storytelling. And Will McAvoy is not a creator; he is a curator. Right? He doesn't make; he interprets. This is from Newsroom. If you have not seen this show, it's pretty good. Although, actually, I will admit that I can only watch one episode at a time because I find it so incredibly stressful. I have to watch like Strike Back, which is basically everything blows up and everybody dies in every episode of Strike Back, and it's just immensely, because it's not like work, or not my job. But the notion of having great storytelling as a coupling, as a partner to coding and to the creation process is incredibly important. And one of the things that Dave McClure said, I think, in that keynote or another one, was that a lot of times modern startups actually kind of miss out on the notion that you're going to have to tell a story around your product. Like they don't think about marketing, right? Because marketing is evil and marketing people are bad. And right straight, the product does sell itself is really so freaking awesome. But the notion of being able to tell a story is incredibly important, even if you're going to be handing somebody something that they can use and play with, which is one of the reasons that getting code out there is so important. So who needs Will Macro? I'd say that if you are a coder, then part of what you need is someone to help tell your story, right? You need to build a mythology. You need it's got to be a little bit more than just the code, in particular because a lot of times one of the dark sides to the shut up and commit, just get it out there, iterate model is that when you hand something to somebody, it kind of sucks. Like it doesn't do a lot of the things you want it to do. And we actually had this experience quite recently. So we demoed that proof of concept for the privacy dashboard in Genevieve's keynote. And a couple of things happen when people have interacted with that internally inside Intel. Number one is, holy crap, I have 1,400 cookies, right? Panic, freak out. And then the next question, like every time, is help me fix them. It's like, why isn't the product helping me? Like, you gave me this thing, you told me that things are horrible and I should be afraid, and you're not helping me fix the problem. So, and you're like, well, we're going to do that maybe in another rev of it. No, but I need to fix it now. Are you kidding me? I have 1,400 cookies. The permissions are all screwed up. The notion of getting things out there early and being a kingmaker, right? Establishing, like, this is who we are, this is what we do, here's our code, here's what it does. If it isn't perfect, and it is early, you got to just sort of armor up for what about this and this and this and that? Gonna get there, it's all gonna be good. The other thing about kingmaker, the kingmaker metaphor, is that kingmakers are not kings, typically, right? Like, kingmakers make kings. And this is something we're trying to focus much more sort of squarely inside Intel and my group from an engineering perspective. There's this notion that in order to get ahead in the engineering companies, in particular bigger ones, and if you've been established for a while, is that like you basically need to grow up out of being a coder and become a manager or a leader or an architect or something, which is a tragedy, right? Like, because if you've got people who are really good at writing code, you should do everything you possibly can to make that better for them and better for you. Like, you should have people who are 20-year veterans who are, top tier from however you rank, whatever your company does. And all they are merely an individual contributing coder, right? That to me is a very good sign of a healthy and thriving kind of engineering organization where people don't think that they basically have to, become manglers. That was what some of my engineers used to call me. They don't have to become manglers in order to be successful because, hey, you're, code talks at the US Walk. We don't need you to decide that you've got to do something different. We just need you to code. And so you really need to, I think, reward it and focus on that. What comes next? Okay, so last but not least, don't have to be as smart as these incredibly smart people, which is a relief to me. We do need to be able to execute. Right? Execute. Shut up and commit. Get the stuff out there. Have someone who's a partner to you who can help tell your story, so they can help interpret it and curate it and make it more approachable, and also help you understand what the hell it is you should do next, right? Because if you're going to get stuff out at 10% of what it would have been otherwise, what's the 11%, right? What's the 1% more that you're going to add? What's the 2% you're going to be smarter at than somebody else? But all of those, you gotta, there's a superpower, I think, in standing for something, for somebody. And there's a hidden clause in there other than yourself or your wallet. We've been using this word on the slide, and I kind of feel like it's maybe overplayed. But to me, the important part of this is that, like, what is the thing that's going to carry you through when you do run into bumps, when they are smarter than you, when they are kicking your ass, when they just did a release of a product that you've been working on for 6 months and they just dropped it, and your CMO sends you email saying, well, I guess we just need to stop our product, right? Because they just shipped it. And so you're not. You gotta have there has to be an inside to whatever it is you're doing to copy all these guys' awesome ideas and go make money with them, or anybody else's. And that to me, a big piece of it is this sort of stand for something, for somebody.